Hello, in this video I'm going to show you my implementation for Milestone 5 of the coding challenge. So what we did in Milestone 5 was to randomize the bombs on the board. It's quite a small milestone. So every time I restart the game, the bombs are randomized on the board, and the board is currently only 8 by 8 cells and 10 bombs. So let me show you how I implemented that. You may have noticed that I added a gray background because my first subscriber, Dylan, said that the white background hurt his eyes. So Dylan, this is for you and also for anyone else whose eyes have been hurt by the white background. And I like it. It's really nice, isn't it? So let me show you the implementation. But before I do, I will just say that if you remember, in Milestone 4, I said that actually the initial status is unnecessary because I can just check if the status is idle and also the start time is null. So initial status is basically when the game hasn't yet started, when you haven't yet exposed any cell, right? So this is initial status. This is no longer initial status. So what I did was to add a helper function, which is called isGameInitial, and it just checks whether the status is idle and the start time isn't null, or is null, sorry. And then I use that in several places in the code. For example, in the stopwatch to set the value to 0 and to stop the stopwatch. And also here, in some random place in the code where I previously checked whether the status was initial. So I changed the model a little bit. I think it's good. I think it's better to have it this way without the initial status, but it was fine the other way as well. Okay, so let's get into it. So remember, we used to have resetGame, which would hard code the board, right? It would just place the bombs and add numbers, just completely hard coded. So what we did now was, what I did was to generate the solution randomly. So let me just show you what that gives us. Or not console log, but console table, because it is a matrix. So let's just refresh. So as you can see, this is the solution. And if I restart a new game, this is a different solution. This is a different solution. The bombs are in different locations each time, right? Here there's a bomb here. Here there isn't a bomb here. And the numbers around the bombs are also correctly generated. So this is basically most of the solution for Milestone 5. And also I generated the cell states dynamically. So the cell states start off as un or unexposed. Remember, solution is the actual, like, where the bombs are underneath, and cell states is like an overlay on top. So it starts off with unexposed cells, and then it can be flagged cells, etc. If you don't remember, look back at solution for Milestone 1, where I explained the difference between the two. And the reason I generated it dynamically is because my code is willing to accept any row count and any column count and any bomb count. So at the moment, it's just, working with 10, 8, and 8. So an 8 by 8 board with 10 bombs. But in future, we'll have the option of doing like a larger board or a smaller board. So let's take a look at how the game solution is generated. So I start off with an empty array, and I fill it with, and I basically fill it with the number of rows that we want. And for each row, I fill that row with the number of columns we want, and they are all set to 0. And then we add bombs. So here I had a bug where I said, okay, let's just iterate bomb count number of times. So 10 times, let's iterate 10 times and just put the bombs randomly on the board. But that's a mistake because sometimes you get the same cell randomly. So sometimes I would add less than 10 bombs to the board. And that is why I have this bombs added counter. And as long as bombs added is less than bomb count, so as long as we haven't added 10 bombs, what we do is we get a random row, a random column. And if that row and if that cell is already a bomb, then continue. Basically, don't increment the number of bombs added. And if it isn't a bomb, then let's add a bomb on that cell and increment the counter. So at this point in the code, we know that 10 bombs have been added to cells, to different cells. So now we have a board with the bombs placed on it and then zeros all around it. So now we want to add numbers around the bombs. So we iterate on every cell of the board, and for each cell, we calculate what its value should be. So the way that I implemented that was to check if the cell is a bomb, then the value of the cell should be BB, right? You're not supposed to change that. What you're supposed to change is the zeros around it. So let's see. So now what we want to do is to count how many bombs there are surrounding this cell. So I start at -1 to 1 and -1 to 1 to basically go all the way around the cell. So for example, if it's this cell, we go this, right? So row goes from -1 to 1 and column goes from -1 to 1 all the way around the cell, if this was the cell. So what I do is I check if it's a valid adjacent cell, which basically checks if I and J are not 0, meaning I'm not at the center cell itself, and the row index and column index are within the bounds of the matrix. And I basically took this out of a previous function, which was exposed cell. Remember, exposed cell also wanted to check the cells around it in order to recurse. So I basically refactored that out and reused the same code for both functions. Okay, so if this is a valid adjacent cell, so basically, like, let's say we're trying to calculate how many bombs there are around this cell. So I want to go here, 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 and count how many bombs there are, right, in each of these cells. And that's the number that should appear here. So if it's a valid adjacent cell and it is a bomb, then increment the value. So this is basically how many bombs there are around this cell. And finally, what we need to do is to return a value that is 0, 1. It's a string, anywhere between 0, 1 to 0, 8. Okay? So that is basically it, I think. And then generate game solution returns the solution that was generated. And reset game, every time you reset a game, whether it's the very first time you load the page or whether you press the smiley button in order to start a new game, reset game will always generate the game solution. So since we know the bomb count in advance, we don't have to calculate it. In the previous code, I calculated it, but now you don't need to do that. And then this is our game. We have the status, the solution, the cell states, which have been generated here, the bomb count, which we received, and the danger coordinates, the exploded bomb coordinates, and the start time. That is our model for the game. And that is basically it. So like I said, I added this background. I added some margin up here. So you're welcome to check out my solution. In the description, I'll leave a link to the solution for Milestone 5 on GitHub. And I'll see you in the next video, where I think what we're going to do is to support like all sorts of game sizes, like beginner, intermediate, advanced. And we can also add support for custom size of a board. Like the user can say, I want 5 bombs and I want 7 rows and I want 10 columns. Okay. So I think that's what we'll do in Milestone 6. So I'll see you in the next video.